involving resistance. All right, but we're going to do this in a very unique way. First of all, we need to understand what a resistance is all about, even though it has been treated some time ago. Yes, it has been treated some time ago. A resistance is that electrical or electronic components that offer resistance or opposition to the flow of current in an electric circuit. Very simple. Alright. Having understood that, we are going to move straight and then solve problems, solve questions using this formula that I have just put in a rectangular um, box. Okay, good. This is when potential difference V is measured in volts, current is measured in amps, resistance R is measured in ohms. All right, we need to note that 1 volt is the potential difference when 1 coulomb of charge transfers 1 joule of energy. Also, conductors have low resistance, insulators have high resistance. Take note, conductors, all right, very, very important. Conductors have very low resistances, while insulators have high resistance. The reason is very simple, but we are going to do details of that in our subsequent classes. Let's quickly move on and then solve 1 or 2 problems or 1 or 2 questions regarding potential difference flowing across a lamp offering some amount of resistance. Okay, and that's the question. Question number 1 and question number 2. All right, so we are going to answer them one at a time. Question number 1 is this. Question number 2 will be found in the next slide. Okay, so let's quickly, without wasting time, solve this question. Let's solve this. Our solution once again is given as a SOLN. I use this to represent solution. Okay, now quickly, the question is, what is the potential difference? Let's pick it out. V, we want to find V potential difference is unknown. Once again, is unknown. Is unknown. This is unknown. Okay, then I always like to use double question marks to emphasize the importance of the quantity we are looking for. That's it. We are looking for what? We are looking for potential difference. It's unknown. Another one, so what is the potential difference if a current, the letter for current is I, a decorated I is given as the letter used for current. Okay, I, current is 2 ampere, that is 2 amps. All right, 2 amps. Okay, good. We take that. So another one is through a resistance. Okay, there is something opposing the flow of current in these circuits. That's what the question is trying to say. What do? We pick out that information. R, resistance R is given as 40 ohms, 40 ohms. Good. Let's write the symbol for ohms. Very nice. Very nice. Are there anyone not properly represented? Are there any ones not properly represented? I think all of them are properly represented. Let's clean off this. We don't need it. We don't need all this. Okay. We now know that V, our potential difference, is unknown. I is current, is known by the value 2 amps. Resistance R is known by the value 40 ohms. So we can do with all that information, because there should be a comma here as a sort of separation, a comma here. Good. So the next thing, we state the formula we're going to use. Generally, we have that potential difference V is given as I being the current, right? Good. And then R And this is also known as Ohm's law. This is also known as Ohm's law. IR. Okay, but we call this equation 1. Good. Now we are looking for what? V. So we can use equation 1, whereby we already know the value of current as 2 amps, the value of resistance as 40 ohms. Okay, I want to quickly clean off these two. Doesn't look nice. And then write a beta 2. Write something good. So let me write something good to represent the value, the number 2. Good. I think this is better than the first one. So quickly we come down here and substitute accordingly. For current we have 2 amps, so we write just 2, and then we put multiplication sign times. For resistance we have 40 ohms, we write 40. All right, we write 40. Good. And then equal to sign. 2 times 40 is going to give us 80 ohms. No, not 80 ohms, 80 volts. Yes, because we are looking for potential difference. So what we have here is 80 volts, 80 V. Very, very interesting. So the potential difference across this resistance is 80 volts. Very huge. That is the voltage. That is the energy being supplied to the system. And because the resistance is large, look at it. This component offers large resistance. Okay, offer large resistance, and then reduce the current to what? To ampere. Otherwise, if the resistance is very, very small, the current would have been very, very large. So that is the implication here. All right, the answer has been found. Therefore, V, meaning the potential difference, is given as 80 volts. 80 volts. Okay? 80 volts. So that is how to solve some questions like these. Don't be scared. Alright? Don't ever be scared. You will solve it and get it correctly. That is what it means. Good. So we have this done. Solved. Interesting, right? The stepwise approach matters a lot because it will help you to understand how to apply this formula and how to solve to arrive at a particular correct answer. Thank you for watching once again. I want to urge you, if you have really found some value in this, subscribe. All right, give us some subscription, give us some thumbs up, share to your friends, to your network, to your friends, to your numerous networks, to your students. Just share to anyone on your platform. All right, we teach all science subjects, and I want you to join us. I appreciate you, my returning subscribers. I appreciate you, my new subscribers. Please belong to this family and promote it as much as you can. Thank you. So let's see what we have in our next slide. In our next slide is to solve another question, question number 2. This time around, we will be looking for the value of resistance when the potential difference across such resistance is 12 volts and current flowing is 2 amps. So let's see quickly, without wasting time. I want us to finish this once and for all and then move on to another topic of interest in our next class. Solution. So we have our solution in this form. Quickly, we have a resistance of a component. Okay, we are looking for R. We are looking for R. Because there is no R, we are looking for R. At this point in time, R is unknown. quickly is unknown. So we are emphasizing that R is unknown by using two question marks. Good. Very, very good. So let's look at, let's say 12 volts, meaning potential difference V is given. V is given as 12 volts. Interesting. So we write 12, and then we write volts. Good. We're going to write it a bit in full to avoid some sort of confusion here. All right, 12, this is 12 volts. Good. Next thing, current is also given. Look at it. Look at current is given 2 amps. So what we do is current is represented by letter I, okay, and then it's equal to 2 amps. 2 amps. Very nice. I need to write boldly so that my viewers can see my writing and then read meanings into whatever they are watching. Good. So we have gotten the information. All right. This information is what the question contains. Now what we need to do is very simple. Once again, we state the formula, and the formula here, according to Ohm's law, is potential difference V or voltage V is equal to I, once again, just like we did in our previous class or previous topic, and then once again we state R. Okay, this is typically what we call Ohm's law. All right, we're going to do that in detail. We're going to explain Ohm's law in details as time goes on, but today we are only focusing on 1 or 2 things that matter because of the topic we are treating at the moment, right? This is known as the Ohm's law. I'm doing this so that we don't get confused. Each time you see me state something like this, I refer to Ohm's law. Good. Now this is Ohm's law. Now what do? We are looking for R. We have been asked, according to the question, to find the value of the resistance of a component when or if 12 volts causes a current of 2 amps to pass through it, to flow through it. So we need to solve it and then arrive at the answer. What do? We make R. The one we are looking for is R. So we make R from this equation, from this Ohm's law, we make R the subject. Let's see. R is made the subject at this point. Very nice. Good. So if that happens, it means that V is now the ratio of ratio to I, that is current. Okay, and then I, that is it. Good. Very interesting. So what do? We substitute. We have V potential difference, which is 12 volts. We write 12 volts, or just 12 for now. Over I is 2 amps. We just write what? 2 for now, after which we put the units. So by the information present here, it means that 12 divided by 2 is going to be 6. It's going to be 6. Good. That is it. That is it. 6 watts. Excuse me. Because resistance is measured in ohms, or rather resistance is measured in ohms. That's what it means. Okay, resistance is measured in ohms, and we continue to have that because we can change that. It's been measured, it's been ascertained, and we will continue to maintain it that way because resistance is measured in ohms. So what we're going to do is to put the symbol of ohms. Very simple. That's all. Therefore, our summary is going to be resistance R The value of resistance R is equal to 6 ohms. 6, all right, ohms. We have to be careful to be able to draw the symbol very well. Good. That is our final answer. We have succeeded in finding the value of the resistance of the components, all right, through which a current of 2 amps passes through and then supplied energy of 12 volts. You can see, very simple. That is it. It's been solved. So with this method, you can solve any simple questions coming from such a topic without wasting time. Don't forget to subscribe. Don't forget to share to your friends, to your network, to your students. Don't forget to give us some thumbs up. All right. Do not forget as well to hit the bell button so that each time content like this is uploaded, you will be among the first set of individuals that will be notified. Remember that this is strictly education. Let others know about it. Promote this channel. Be part of this channel, because we're going to teach things like this every day, every moment, and posts for your learning pleasure and enjoyment. All right, let's see what we have in our next try. Yes, here we're going to say a very big thank you, because you have really proved to us that you are part of us. Okay, this is the point. We seek your support. We seek your support at this point in time, and then ask you to do what you can do for us is to support our channel. All right, support our channel, subscribe, and then give us some thumbs up, as I've always said, right? Kindly support this learning by subscribing, liking, sharing, and giving the video some thumbs up. Yes, we should do more than this, because I know that we can do more than this pretty well. Good, 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 and good. So let's see, because I know. Good. Thank you for watching. Thanks a lot for watching. All right, because we want you to always support us. So with that, we have come to the end of this lecture, to the end of this class. Thank you so much. See you.